Have you ever spent Canada Day looking into the pretty lit up sky filled with beautiful colors and sparkles?
Haven't you ever wondered how color can explode in the sky?
Haven't you ever wondered how fireworks are made?
Well, like everything in the universe, there's chemistry behind it.
To start off, fireworks were created by accident in ancient times, around 200 BC.
It originated in China when a cook mixed together three elements: sulfur, carbon, and lastly, potassium nitrate.
These three elements exploded, and thanks to his mistake, we now have fireworks. So there are 5 parts to a firework. Number 1, the tail. Number 2, the fuse. Number 3, the charge. Number 4, the effect. And number 5, the head.
The tail or stick is usually a long, straight wooden piece that ensures in which direction the firework will head to. This is quite important because fireworks are pretty dangerous and can cause a lot of damage if headed in the wrong direction.
The fuse is the part where we light it up with either a match or a lighter. Although the ones that we go to see on Canada Day and other big celebrations are usually bigger fireworks and need to be lit up electrically.
We then have the charge, known as also the motor, which is packed with explosive gunpowder.
This gunpowder is made up with 75% potassium nitrate, 15% charcoal, and 10% of sulfur.
The fuse is the part of a firework that we call the blast off, which shoots up the firework off the ground at a very high speed into the sky.
Then for the 4th part, we have the effect. The effect is meant for the visual part that we as spectators watch. The effects are explosions of a whole bunch of small pellets of black powder, which are called stars.
Lastly, we have the head, which is the top part of the firework that allows it to rise up faster and giving it a better direction straight up. Through chemistry, we understand that a firework is a series of chemical reactions happening repeatedly.
The explosion of fireworks consists of a chemical rich in O2, which we know as part of the diatomic elements. Secondly, the firework needs fuel to ignite, which are commonly charcoal, which is carbon, or sulfur. And lastly, we need heat, which can be fire or heat cooked up by electricity.
The oxygen, known as the oxidizer, the fuel, which is the charcoal, and the heat, which is fire, all will work together to create combustion.
A very important part of physics speaks upon the conservation of energy, which states that energy cannot be destroyed or created, but only transformed or transferred.
Therefore, all the chemical energy that is in the firework before it explodes is equal to the energy after the explosion.
The chemical reactions contained inside the firework before it ignites then converts into light, sound, and heat energies.
This explains the big boom you hear when they are in the sky. We understand that fireworks are an exothermic chemical reaction. Now you may be wondering,
how do all these fireworks have colors?
Well, the colors are made by burning metal salts. By burning different kinds of metal salts, you get colors, just like us right now.
Here is an example of burning different types of metal salts. If you're looking to create a red firework, you would use strontium salts. For a blue color, you would use copper salts, or for yellow, sodium nitrate.
So now you're all experts on how to make a firework. And fireworks are just basically a good result of chemistry and physics.
But wait! Don't think you're too much of an expert because fireworks are really dangerous.
Do not do this at home.